Is Prof. Razif already here?
Hi. Yep, I'm
Uh,
here, Prof. Sabto.
okay. How are you, Prof?
Yeah, good. How are you?
Yeah, I'm good. I'm good. It's already evening there, right?
Yes, it's already.
But it's
Um,
yeah, you still look fresh. That's good.
oh, okay.
Excellent.
Still energized.
Yeah, yeah, yeah. Yeah, oh, that's Bu Rizky. Good afternoon, Bu Rizky.
Good afternoon, Prof. Sabto. Good afternoon, Prof. Razif.
Good
It's nice to
afternoon.
see you again.
How are you?
I'm fine, I'm fine.
All right, good.
Um, Masuki, I'm sorry, I'm just having coordination with in the class. Elang, hello, Elang. Yeah, it's already set up there. Cukup jelas suara?
Ya, ya, jelas
Suara
bro.
cukup jelas ya? Oke, oke then. For the presentation, I think you all students got already the presentation, right? Putra, sudah semuanya ya Putra ya? Ada masalah yang presensi, ada yang masalah? Wait, Prof. Razif, just make sure presentation already okay for the student. Okay, wait. Please raise hand for the students yang belum bisa presensi. Tolong raise hand atau speak up mungkin ya.
Maju mungkin.
Ya, wait. Agnes ya, Agnes. Kenapa Agnes?
Halo Bapak, izin Bapak, saya Agnes Siregar. Saya
Ya,
izin bisa ikut hadir langsung di kelas Bapak karena saya sakit Bapak. Jadi
oke
saya
oke.
ikut saja.
Zoom ya. Oke oke oke. Yang lain?
Sini ada yang belum bisa. Siapa? Siapa namanya? Sini aja sini.
Siapa Lang?
Nah, ada berapa di kelas? Benar. Tulis aja ya. Yang belum saja ya. Tulis sendiri. Betul ya. Langsung aja.
Don't speak up.
Udah habis. Oh, udah habis. Iya. Ya tulis aja. Oh, tulis aja berarti. Saat.
Tribuana, Tribuana hadir ya?
Hadir.
Hadir ya? Oke. Ini soalnya belum presensi kamu. Akmal,
Tidak ada, Bro.
tidak ada ya. Zuhruf,
Hadir.
Adif, ini kamu belum setting. Galuh,
Ini yang di kelas nanti saya list aja dari saya sebelum biar
oh iya ya, langsung kirim ke saya ya. Oke kalau gitu.
ini
Oke
sudah
then.
kertas.
Ya, oke, that's great. Maybe sebentar lagi ada semacam kayak Google Form nanti diisi aja ya. Masuk ke itu nanti chat ya. Oke.
Tapi di tengah-tengah.
Oke, Masuki, Elang sudah bisa dimulai ya?
Bisa, Bro.
Iya, well, thank you for organizing this ya, Masuki and Elang ya. Uh, Good afternoon to evening ya, Prof. Razif Harun. He is the senior lecturer ya in UPM Malaysia. UPM Malaysia is one of the best university in Malaysia. The QS World ranking is 138, if I haven't mistaken. Is it correct, Prof. Razif? Yeah. So
Yeah, Prof.
138.
Sabto, the latest one 124.
1124, 124.
Yeah,
Wow.
124.
Excellent, excellent. Congratulations then.
Yeah.
Yeah, you can, the students are really enthusiastic to hear the program called Undip Classroom, which is one of the effort from Undip to expose the students to have experience in an international class. Yeah, although now it's in an online-based education system, but in the next period they will have a chance to go abroad. So this is the step-by-step program, World Class University from Undip. Yeah. So we will catch up the great achievement from UPM Malaysia. So today we will having a lecture of the senior lecturer from UPM Malaysia, especially Faculty of Engineering, right? So actually today Prof. Razif will talk about the microalgae as biofactories for sustainable application. This is one of the solutions to reduce the potential impact of the environment. So by biofactories in sustainable way means that the environment, we pay attention, we respect the environment as the subject of today's lecture. Yeah, the subject of today, the subject is environmental science. So the class is about environmental science as well. So I think this is very relevant for this class, for today's session. Okay, so please don't hesitate to ask. Ya, jangan malu-malu. Ya, even in bahasa Indonesia, Prof. Razif sangat bahasa Indonesia because he come here several times ya in Indonesia. So we have same language ya, cuman dialeknya sedikit berbeda. Berbeda di sana berbeza. Prinsip sama ya. Kalau bahasa Malaysia di sini yang familiar itu bahasanya Ipin Upin. Tapi kalau sudah sampai Malaysia, saya kadang lupa kalau saya sudah masuk ke bahasa Malaysia. But basically we are the same language. So I'm very glad for today, Prof. Razif, and you have able to give lecture for the students to give some science experience, especially specific on microalgae as biofactories. So please welcome you. I think Bu Rizky, you want to be a moderator? Is it okay for you?
Okay.
Okay.
It's
Okay, please.
it's kind of
Thank you.
surprising for me because I'm suddenly become a moderator in here. Okay, good afternoon, everyone. So thank you, Prof. Sabto. to make me a certainly moderator for this evening. So my name is Rizky Zandi Titisari. Maybe I'm not a lecturer for ilmu lingkungan, but because I'm excited to learn the materials from Prof. Razif, that's why I'm joined to this Undip Global Classroom. So, however, I'm happy to share that I have interest the continuation of this moderation to one of my advisor, from my senior lectures. So, okay, let's give, before we begin, allow me to introduce our distinguished speaker for the day. He is Prof. Razif Harun. On a personal note, I think this is not certainly the very first time I have the pleasure of meeting him. So we have crossed paths on several occasions, and every interaction has been really enriching his depth of knowledge, especially in microalgae engineering. And I'm genuinely delighted that today he will join us to share his expertise with our student in the class. So, Prof. Razif, it's always a joy to have you with us. Thank you so much for making the time. Okay, with that, without further ado, allow me to welcome Prof. Razif to the floor. So, Prof. Razif, the stage is all yours. Please go ahead.
Right. Thank you very much, Miss Rizky. And then first of all, I would like to thanks to Professor Sabto for inviting me to, sharing the expertise related on microalgae in his class for today. I think it's very great honor for me to meet everyone for this afternoon. Right. So I think today I'm going to share a basic concept or a basic introductions of microalgae. I believe that this is just a starting, it's just a beginning. And then we will have more sharing session after this on the specific topics. So what I'm going to share today is about a very basic introductions about microalgae. Perhaps if you guys have any questions, you can directly unmute and interject me during my presentations. I'm okay with that. So it's not like a very formal setting. We try to make it more casual so that we can interact and become a very exciting sessions for this afternoon, right? So first of all, allow me to share my slide for today, right? Does anyone see my slides on the screen?
Yes, we can see it, Prof.
All right. Okay. Thanks. Right. So this is the topics that I proposed to Prof. Sabto on the microalgae as a biofactories for sustainable applications. So before I deep dive into the topic, like in Malay saying that tak kenal maka tak cinta, right? So let me introduce myself first. Although there is a brief introductions by Professor Sabto and Miss Rizky at the beginning of the sessions. So let me, introduce again myself. I'm Razif Harun, currently a Deputy Dean of Graduates and Internationals. And I will end my contract as a Deputy Dean next year in March. And then after that, become a normal person back. I'm currently from the Department of Chemicals and Environmental Engineering, which my department, offering a bachelor degree, Bachelor of Chemicals Engineering with honors. And we also offer the master's and PhD programs at our department. So if you would like to, know more about the programs, you can directly contact me. You can email me or you can WhatsApp me. So I will give the informations. So basically my background's on the biochemicals engineering. To be honest, I started my microalgae journey when I started doing my PhD. So I received a scholarship from the Ministry of Higher Education to pursue on my PhD in Australia back in 2008 until 2011. Which my project is actually producing biofuel from microalgae. So during that time, microalgae is very, very hot topic for productions of biofuel. My PhD project focusing on the biodiesel and bioethanol from microalgae. So since then, after I completed my PhD, then I came back to Malaysia and got a position as a senior lecturer at University Putra Malaysia. And then after 2 years, I got a fellowship for my postdoctoral study. So I was in France for 2 years. So it's actually why I decided to go to France because I would like to challenge myself. France, they don't speak English. They only speak French. Where if you look at my backgrounds, my bachelor degree and my PhD from the English background country. So I just want to, break my comfort zone. So I spent 2 years in France. It's actually I can speak French now. But I think after a few years, when I came back and then nobody can speak French, so my French is not really strong at the moment. But I still can understand, and then I can read and I can communicate in the simple French language. So I was in France for 2 years doing on the biogas productions from microalgae. I was attached with Airbus company, one of the giant company to produce the aircraft where we are producing the jet fuel for Airbus. So 2 years I was in France, and then after that I came back to UPM, and until now become a lecturer at the Department of Chemicals and Environmental Engineering. So my background on the biochemicals engineering, particularly on microalgae, I'm looking at the upstream processing where I producing the microalgae and extracting the compounds from microalgae and producing various products, including the biofuel, pharmaceuticals, as well as the food. And then feed for animals. So this is basically a brief summary about my backgrounds, right? So if you would like to know about microalgae, you can directly contact me, or we can have discussions in details later on, right? Okay, so coming back to our presentation for today, I'll start with the introductions of the microalgae, and then I'll go in terms of reviewing on how can we produce a microalgae, and then what are the products that you can derive from microalgae, and then we would like to see whether this product has some value at the moment in the market, and then I'll end with some discussions about the issue and challenges of microalgae so far that we are facing, right? Okay, so before we start into my lecture, I would like to ask the audience in here, if you look at this photo, right, do you think this is algae? I know you have some backgrounds, or some of you doesn't have background, so it's okay. You can guess whether the ones that we see on my screen at the moment, do you think this is algae? Can I get some response from the participants? Anybody would like to try?
Tolong di-mute punya Bapak. Okay, dear our student,
Yeah.
I would love to see some hands up in there. So please, one of the student, can you help us to answer Prof. Razif question?
There is a no right or wrongs. Prof Sabto will not deduct your marks. It's just like just guessing.
Okay, maybe Putra can help Bu Rizky to answer the question. You can raise your hand and stand up so we can see your face clearly. Putra? Okay. We cannot see your face clearly. Is it okay if you come to the front of the class and answer the question because we cannot hear your voice from Zoom meeting? Oke. Menurut Putra, ini algae atau tidak? You can speak in Indonesia. I believe Prof. Razif will
Yes,
understand
betul.
Indonesia language.
Bisa. Tapi suaranya tidak dengar ya.
Ya.
Mungkin itu termasuk mikroalga karena airnya juga berwarna hijau.
Alright, okay. Very good. Ya, betul. Ini adalah algae. Sebab yang pertama adalah colornya hijau, kan? Kita biasa kenal algae ni colornya hijau, alright? Tapi not all the green layer on the surface of water is considered algae, right? So this is right. This is we call it as an algae bloom, right? Okay. Later I'll explain why we call it as an algae bloom. Right. The second guess. This second photo, I would also like to ask you, does it algae? Because just now, Putra mentions that is it algae because it's a green, right? But this one, you can see is a pink color, right? So does it algae? Because we also have in our mind, algae is a green, but this one, pink. Is it algae? All right. Anybody would like to try?
Okay, anybody in class? I would love to see some hands up in there. Maybe one of two students. Or maybe Rehan. Rehan, are you there in the Zoom meeting? Can you answer the question? Does it algae or not?
Rehan must be a popular student, right? Because
Rehan actually one of my student under
All right.
supervision, my supervision and Prof Sabto, and he
All right.
joined
Okay.
us in the Zoom meeting. Okay, Rehan, are you there?
You are lucky, Rehan.
Thank you. Yes, I'm here, Buski.
Okay, can you
Yes.
can you answer the question?
I think from what I'm seeing, this could also be algae, since what I have heard that there are some algae with different colors due to their pigments. So I could say that this is one of algae species, and I'm apologize if I'm wrong. Thank you.
All right, very good, Raihan. Yes, this is algae. You are totally correct. Right? Not all the algae is a green. Algae can come from red color. It can come from the pink color. The reasons that this algae bloom is a pink color because it has been toxified by runoff fertilizer during the raining season. So there is a runoff water from the agriculture farms nearby during the heavy raining season, and then they bring that fertilizer, I mean chemicals, into the water and mix with the algae, so the algae turns into pink. So this has happened last year in Malaysia, in north part of the coastal area, right? So yes, this is algae. So not all the algae is a green. Algae also has many colors. Okay. All right. So we call it as a pink algae bloom. Just now it's a green algae bloom. Right. So the third one. Right. So is it algae? Is it green? Right. So there are also a bloom, but does it algae? Any lucky names?
Okay, we will find the lucky names from the list of our participants for the day. Maybe Fionina can help Rizky to answer the question. Fionina, are you there? Aduh, Fionina. Ada ya? Or maybe Ulia Agassi?
Baik Ibu, mohon maaf saya belum bisa untuk on cam karena satu hal. Menurut saya pada gambar tersebut itu bukan termasuk alge karena warna hijau yang terdapat pada gambar itu hanya pada bagian atas, sedangkan untuk airnya tidak mengikuti warna hijau karena biasanya untuk algae bloom itu berwarna hijau hingga ke air-airnya.
Okay, thank
Okay.
you, Ulia, for answering the question.
Yes, thank you, Olia. Yes, you are right. This is not the algae. We call it as a duckweed, right? So duckweed is basically the floating plants. It's actually if you have the duck on the surface of the lakes or ponds. So this is part of makanan. They call it what? Itik. Kami di Malaysia panggil itik. I'm not sure in Indonesia. So duckweed is basically is a floating freshwater plants. It's not organism, which is my algae is organism. So duckweed is a plant. Although it looks like algae bloom, tapi ianya adalah plants dalam kategori plants. It's not microorganisms or organism, right? So basically we use this duckweed as a animal feed sebagai sumber makanan kepada haiwan because it has a very high protein contents, right? So try not to, confuse between algae and the plants, right? So yeah, the last one that I would like to ask you, this one, algae or not, or a plant? Last one.
Okay. Karena tadi sudah dari Zoom meeting, sekarang mungkin dari kelas, mungkin ada salah satu dari student yang bisa menjawab. Mungkin yang di depan yang pakai baju kuning jilbab hitam bisa bantu Bu Rizky untuk berdiri ke depan untuk membantu menjawab to answer the question from Prof. Razif. Iya, yang pakai baju kuning jilbab hitam. Aduh. Ya, oke. Atau dari salah satu student mungkin bisa membantu Bu Rizky untuk menjawab pertanyaan dari Prof. Razif.
Okay, tak apa. Saya jawab sendirilah kan. Tak
I'm
apa.
sorry, Prof. Razif.
It's alright. That's
Okay,
alright.
there's some
Raihan.
raised hand in
Yeah.
the Zoom. Okay, Rehan,
Yeah,
do you
please.
want to answer the question?
Yes, if I'm allowed, I would like to answer the question. So from what I'm seeing, I think this is algae, but precisely a macro algae that has been washed out into the shore, if I am correct. So I think that would be my answer. Thank you very much.
Yes, absolutely correct, Mr. Raihan. Yes, it's a type of algae, but this one is a brown seaweed, we call it, right? So if you love eating sushi, the one that wrap the sushi is actually a green seaweed. This is a brown seaweed that normally you can get from the coastal area. So what I try to show to you is actually not all the green that been bloom on the surface of water is the algae. And then algae also come with the different color. And then algae also come in the different shapes, variations, size, and whatnot, right? So this is basically the seaweed. Okay, right. So coming back to the definitions of algae, right? So just now I was mentioning about not all algae is a green. And then you have to distinguish between algae and plants, right? Algae is basically not a plant, but it behave like a plant. Why it behave like a plant? Because it undergo photosynthesis process, right? So when it undergo photosynthesis process, it considered as a non-flowering photosynthetic organism. So it's an organism, it's not a plant. Ranging from the microscopic, that we call it as a microalgae, to the macroscopic of marine algae or seaweed. So you have two category of algae, which is micro, which is when we talk about the micro, you cannot see using your naked eyes. So you only see a green solution, a green liquid, or a green bloom without seeing the single cell, whereby the macroalgae, like I highlighted previously, seaweed, considered as a macroalgae, where you can see exactly how it looks like, right? If you deal with the microalgae, you have to use a microscope to see the cell. Because using your eyes, you cannot see the cell. You can only see a green liquid, right? So you have to distinguish between the microalgae and macroalgae. Right. So now we will see the difference between the macroalgae and the microalgae. So we look at the first macroalgae. So microalgae, like I said, is in a macroscopic cell, which is can divided into red algae, brown algae, and green algae. So normally, this macroalgae, the applications of the biomass is basically for food applications, as well as there is some applications in the clinical, like for example, it contains high carcinogens for the dental implants and whatnot, right? But it doesn't been used for biofuels or other high value products, right? And then the next one we would see in terms of the microalgae. Like I said, microalgae, you cannot see the cells. You have to examine it under the microscope to see the cell, which microalgae you only can see the green solutions, right? Okay. Microalgae, we can divide it into a different category. We have blue-green algae like spirulina, and then we have green algae, chlorella and whatnot, and we have red algae, and then we have the diatom. So each of the microalgae, we have a different applications because they are the biofactories. They contains a very valuable biocompounds that further can be extracted from the cell and producing many products for different applications, right? Later, we will see what are the potential products that can derive from microalgae. Right, so the scope for today's sessions, I only focusing on the microalgae because of course my work, I have been working with the microalgae for producing various high value products, okay? So maybe some of you wondering why people are very interested in microalgae, right? So let's look in here that the number one is microalgae can grow anywhere. It can grow on the surface of the water. It can grow on the land because if you have the rector or the vessel or the container, you can grow it in the container on the land. So for the area that doesn't have much land, so you can culture this microalgae in the pond, river, or in lakes or any surface water that you have. Of course, with we call it as a photobioreactor. So it can grow anywhere. So this is one of the advantage of the microalgae. And then it has a very high productivity. For example, if you producing a biofuel from corn, for example, in Brazil, they have been producing biofuel, biodiesel from corn, which to plant the corn, it takes around 5 to 6 months to get the biomass to produce a biofuel. But with the microalgae, it has a very short harvesting cycle that you can get the biomass within 2 weeks, from 1 to 10 days. It depends on the environmental conditions that you have at your area. So compared to the other biomass that become a feedstock for biofuel, it has a very huge advantage because you can get in a very short cycle and you can produce the biofuel in a very consistent way, right? The third one, it can be grown either using a marine water or the fresh water, right? So we know that fresh water are very important for our daily activity. We're using the fresh water to for drinking, for shower, and for other purposes. But we can grow the microalgae without a fresh water. We can use a marine because we have the marine species of the microalgae. So it reduces in terms of the dependency of using fresh water to produce the microalgae. Okay. And then the huge advantage of this microalgae, it can capture the carbon dioxide because as starting just now, I was mentioning about this microalgae undergo photosynthesis. So when it undergo photosynthesis, it capture the carbon dioxide and then producing the sugars and oxygen. That oxygen is utilized by human, right? So that's a cycle. So when you reduce the carbon dioxide from the atmosphere, then it directly can reduce in terms of the greenhouse gas emissions, right? So for the area that have many industrial activities where they release a lot of carbon to the environment, so we can put the microalgae system nearby the industry so that they can capture the carbon released from the industry emissions, and then they can utilize to produce the microalgae cells, then further can produce a product. So compared to the trees, microalgae has the capability to capture up to 50 to 200 times more than the trees. So meaning that it can capture more. So this is something that the things that we are currently doing, the project with our energy producer in Malaysia. So we install our microalgae system next to the power station that when they release the emissions, then we capture the emissions to the microalgae system. So it can reduce the carbon, hence it can reduce the effect of climate change in our country, right? So this is one of the great advantage of the microalgae. And then the last one, of course, it has been biofactories. It has high value biocompounds. Later, I'll show to you what are the compounds that you have in microalgae cell that has potentials to produce a product, right? Okay. So just a quick comparison in terms of oil productions from the microalgae. This is one of the key findings that why microalgae is a good, it's not just a good, it's a great materials to produce a biofuel. Because if you look at the oil content, compared to the canola, compared to the soil, jatropha, or palm itself, microalgae has huge potentials in terms of the oil percentage to produce the biofuel, right? Then this is something that also we have been doing to produce the microalgae for biofuel. So it has a very high oil content in the cell. but depends on the species of the microalgae. So to sum up on the advantage of the microalgae, is the scalability. You can scale up the productions of microalgae according to the area that you have. And then in terms of productivity, because it has a very short harvesting cycle with a very high productivity of the biomass. And then in terms of sustainability, in terms of the economics, in terms of the social impacts, also in terms of the market potentials, the product that coming from the microalgae. And these microalgae can be genetically modified. For example, if you want the species of the microalgae has a very high protein, so you can genetically modify the DNA and whatnot in order to boost up a certain biocompounds in microalgae. So we have a team as well, the team that coming from our Faculty of Biotechnology. They are doing on the transgenic microalgae, where they alter the DNA and whatnot of our microalgae to boost up in terms of the oil contents or protein or carbohydrate content. So it can be genetically engineered, right? Okay, right? So let's look on the microalgae productions, right? So it's not too difficult to produce a microalgae. What you need to do is you need to have four components. Number one is you need to have carbon, which is coming from the CO2, carbon dioxide. It's either you use the carbon dioxide from the air, because in our environments, in our air, it consists of CO2, or you can use the CO2 that released from the industrial processes, or you can use a pure CO2 that you can purchase from the industry. Okay, so the CO2 is a carbon source as an energy source for microalgae. Of course, you need the sunlight as the energy because photosynthesis it requires a sunlight, and then you need to have the nutrients to grow. Like us, every day we have to eat. Our breakfast, lunch, and dinner, where we have to make sure that we have a balance in terms of nutrients, protein, carbohydrate, fats, and whatnot in our food. It's the same like microalgae. You have to supply them with a good nutrients so that they can grow well, and then at the end of the process you can get a very high quality of the microalgae cell, right? Okay, so the overall process to produce the microalgae, first you need to culture the microalgae, where the terms that we use is a cultivation, or some of the country they're using farming, microalgae farming, or microalgae cultivations, or microalgae culturing, right? And it's once you have the cultivation process where you produce the cell, and then you have to do the harvesting, because normally in 1 liter of microalgae culture, you can only produce 10% is a solid, which is cell, and 90% is a water, which is the nutrient. So you have to remove the water to get the biomass. So that the biomass require the harvesting, or we call it as a dewatering. So after we get the microalgae, we call it crude microalgae or paste microalgae, then we have to extract to get the compounds. Either you want a protein, or you want the oil, or you want the carbohydrates, then you have to do the extractions. This is the work that my team expertise on this, because we have been using a different technologies or methods to extract the compounds from the microalgae. And then later, once you have the compounds, then you do the purifications to get the high value microalgae products. So this is basically the chain of producing the products from microalgae. Okay, so like I mentioned previously, it requires lights, carbon, it requires nutrients as a food source, and it requires water because microalgae cannot be cultivate or culture on the soil. It doesn't have any water. It should be floating in the water. So it requires a water as an agent for them to grow. Okay, either you use fresh water or you use a marine water. Okay, right. So let's look on the systems to culture the microalgae. So we have two different systems to culture the microalgae. Number one is we have open cultivation system. The second one, we have closed cultivation system. When we apply the open cultivation system, we have like a pond system. We call it as a raceway pond, or we have the circular pond and different design. But when we call it as an open pond, you can culture the microalgae in a container that doesn't have any cover in it. So it exposed to the environment, then with time, it producing the microalgae biomass, right? So that's the open cultivation system. So the second one is a closed cultivation system where you have, we call it as a photobioreactor, right? So I'm sure that you have been, learning about the reactor, but in the microalgae, we call it as a photobioreactor. Photo coming from the lights, because your photobioreactor should be supplemented by the lights because it's a source of energy during the photosynthesis process to grow the microalgae. So if you can see that in this our photobioreactor, we install the LED lights inside to power up the culture so that it has a consistent productivity. So it has a different design, flat panels, we have bubble columns, tabular reactors, we have even plastic bag reactor. So it depends on your purpose. Either you want to produce in a very high light intensity, very high temperature, in the outdoor or indoor, it depends on your conditions. But this is the examples of the closed cultivation system. So remember, we have two open system where we just like a ponding system. And the second one, we have the closed system where we use photobioreactor. Okay, right. So this is the pro and cons when you have the closed system and open pond system. Looks at first at the open pond system. The advantage of the open pond system is easy to construct because there is a less accessories or there is a less sort of like how can I say? There is a less mechanical things that you attach on your system, right? It's easy to construct. Of course, because of a less accessories, it has a less energy requirement, but you can produce the microalgae in a large quantity because you can design in a big pond to produce a microalgae. But the downside of this open pond system, it requires a large area if you have a very limited space. So this is not the good options for you to choose in producing the microalgae. And then the second one, it has a very high risk contaminations because you open up your culture to the environment. Maybe the bacteria or other pathogens can come into your system and it will contaminate your microalgae culture because it's open. There is no barrier that avoid the cross contaminations from the bacteria or protozoa. Because of that, it has a very low biomass productivity. And then in our tropical countries like in Malaysia, in Indonesia, Philippines, our temperature is very high. And when you culture the microalgae in the open pond system, then it prone to the high evaporation, right? So for example, you start with 10,000 liter of microalgae culture. In the next 3 days, you will lose 10 to 15% of the volume because of we have a very hot temperature. right? Because we use water, so it tends easily to get evaporate. And it can only suitable for few species, right? So the second one that we have a closed system, because it's a closed, it's very good control of the parameters. Because normally in our photobioreactor, we install the sensor, like for example, the temperature sensor, the pH sensor, the dissolved oxygen sensor, CO2 sensor, and all the sensors. So with the sensors, we can control on each of the parameter when culturing the microalgae. So because of that, we results in high growth rate, and we have a very little contaminations. Although we cannot avoid the contaminations, but we can reduce in terms of the risk of contaminations. But the downside of the closed system, your capex and opex are very high, meaning that capital investment and operations of that, because it require maintenance, so it indicates some cost to that. And then it producing the biofilm formations, because normally if you don't mix the culture well in your photobioreactor, so there is some depositions of the microalgae cells on the surface of your photobioreactor. So it creates a biofilm, and it reduces the penetration of the lights from outside to the inside culture. Okay, so that's why it has a very low in terms of productivity, right? Okay, so that the pro and cons of the open pond system and closed system. Okay, so you can see later I will share the slides to you. So this is some of the tables that you can use, which system that you can choose, either open pond system or closed system, based on your requirements. For example, if you want to have a less maintenance, open pond system would be good, right? So you can use this matrix for your decision making on which system that you can choose. Okay, right. So the next one, now we already know about the microalgae production system, where we have the open system and we have a closed system. And then each of the system, we know what are the advantage and what are the limitations of that. But when we producing the microalgae, we would like to know inside the microalgae cell, what does it have, right? So we call it as a biofactories. Okay, so inside the cell, this is a very generic composition. Of course, this composition will be different from species to species. Either you use a marine species or you use a freshwater species. So the general composition is showing in this slide. Okay, so in one cell of the microalgae, normally it consists of lipids, right? Lipids is basically the oil or the fats that you can get from the cell. So normally lipids contain around 20 to 30% of the dry weight. So for example, if you have 1 gram of microalgae powder, so it's actually you can get around 0.2 gram of the oil. But again, like I said, it depends on what species of the microalgae. Some species contain 60% of the oil. Some species contain only 10%. So it depends, right? So, but normally it contains around 20 to 30% of the lipids, which is the oil. The largest compositions of biomolecules in microalgae cell is a protein. Right? So it consists around 50 to 60%. So this is something that people extracting the protein from the microalgae for animal feed, for human supplement, and the other applications like amino acid for nutraceuticals and pharmaceuticals applications, because it has a very high proteins. The third one, it consists of carbohydrates. Carbo is basically sugars. So the sugars can be used to produce the bioethanol, right? So this was the project from my PhD, that I extract the carbohydrate from the microalgae cell, and hydrolyze it to produce a simple sugar. So once I have the simple sugar, then I do the fermentations and producing the bioethanol as a bioenergy or biofuel. So normally in one cell, it contain around 10 to 30% of the carbohydrates. Okay. So the rest of the composition is very important. We call it as a pigments, or it categorized under other compounds. So these pigments, I think you heard about chlorophyll, you heard about carotenoid, and all those biomolecules that is actually has a very good advantage or benefits for pharmaceuticals and nutraceuticals applications. Is an anti-aging, antioxidant, anti-obesity and whatnot. So they are very strong biomolecules for the high value productions, right? So this is basically, we call it as a biofactories, that in one cell you can get multiple compounds. It depends on your applications. Then you can extract out these compounds to produce a product, right? So let's see what we can get the products from the biomolecules that we have. So it depends on your interest, or it depends on the industry portfolio, whether they are coming from pharmaceuticals industry, or if you are very interested to do research for microalgae in pharmaceuticals applications. These microalgae can supply in terms of the peptides, antibacterial vaccine, that can produce the alternative or green molecules for health products, right? So microalgae also has a high protein that can be applied in the food and nutritional industry, that it consists of carotenoids, polysaccharides, there's an antioxidant, and it can become a food security approach to the existing market. This is something that we are currently doing. One of our team producing the health supplements from the microalgae, because we extract out certain biomolecules that basically has a very positive impacts in terms of antioxidant activity in our microalgae, right? And then the one that people have been interest with is on the bioenergy. So this microalgae, you can produce bioethanol, hydrogen, biogas, also biodiesel, that can produce as a renewable energy on top of the solar, wind energy, and then the other renewable energy. This microalgae can become one of the options for sustainable energy. And then agriculture applications, just to let you know, UPM, our niche area is about agriculture and food security. Our university name previously is we call it University Pertanian Malaysia. So we changed the name from Pertanian to University Putra Malaysia in 1997, because when we put University Pertanian Malaysia, people have a misunderstanding that we only offering the Pertanian program. It's actually we don't. We have engineering, we have social sciences, we have medicine, veterinary, and whatnot. So the university decided to change name to University Putra Malaysia instead of University Pertanian Malaysia. But having said that, our main focus is still on the agriculture, and whatever the research that we're doing in university should tailor to the agriculture and food security. So at the moment, our team have been secure several research grants to apply this microalgae to the agriculture activities. Like we tested our microalgae as a fertilizer for local vegetables, to the durian trees, as well as with rice farming industry for the paddy cultivation. So it has a very good, in terms of the result. Maybe I will invite everyone to come to UPM, and we will bring you to showcase on our applications of microalgae with different industries. Okay, and then microalgae also can be used in the manufacturing industry. It can produce the bioplastic, biocomposite, textile, and then it can be a bioconcrete as well. Then it's at the end it creates a sustainable and green products, right? In the manufacturing industry. Okay. So maybe I'll stop for a while, and then if you have any questions, maybe we can get some from the participants, if you have any. Otherwise, I will continue. Does anybody has any questions? No? All right. So I take it no. So I will continue for the next one. All right. So when we look at the microalgae market potentials, all right. So it has been projected that the value market of microalgae increase year by year from 2019, and is projected it will be increased 5% more in 2027. So if we look at this chart, most of the microalgae has been used in food and beverages, like in Korea, in Japan, in Taiwan. They drink the microalgae like Chlorella spirulina for their health supplements. Of course, the applications of the microalgae for pharmaceuticals, for fuel, nutraceuticals, and I think the second top one is they have been using the microalgae as an animal feed because it contains very high protein. It can replace the soy as a main ingredients in the animal feed. Then they feed the microalgae to the animals, and the animals, grow very well, and they have a very good quality meats and something when they consume the microalgae. So this is part of the industry that has been utilized the microalgae for their businesses, right? Okay. Right, so this is some of the distributions of the giant company that has been producing the microalgae around the globe. But Malaysia is still not on the map because we are not yet to establish. We still on the R&D. I think there is a one or two companies that have been ventured into producing the products from microalgae in the commercial scale. But other than that, they are still doing a pilot testing, not really commercial. But if you look at the other countries, like our neighbor, which is Thailand, they are producing the microalgae as a food. Also, they are producing the dried algae, and then they selling that microalgae. But the other countries, they have been making it as a big business to them, right? Okay, so this is the examples of the market price of the existing products. So I took the examples of the Chlorella. Chlorella is a green algae. It's become popular because it's easy to grow, and it can adapt in a very harsh conditions or whatever. So it's a very good microalgae species. So Chlorella. So if you have Chlorella, you can make it business selling Chlorella as a Chlorella biomass, the whole biomass. You don't need to process it to produce a product or whatnot. You can selling it as a Chlorella, which is the current price is around 450 ringgit per kilogram. I think it's around 1.5 million rupiah, the cost for 1 kilogram. But it depends on the quality. But this is the average price for the Chlorella. And then some company producing chlorella as a food. This is the examples that they make it as a crackers, like biscuits, right? So if you look at the ingredients, they only put only 1% chlorella in it, but with the 1%, you can selling it as a very high nutritionist crackers. So you can boost up in terms of the price because you use chlorella that has a very good antioxidants, anti-inflammatory and whatnot. So, but inside here you only use 1%. So it's a very good business. Okay. And then you can use as a feed for animal. It's around USD 1,600 per 23 kilo. This is the average price. And you can selling it as a plant fertilizer. This is something that we are currently developing on microalgae biostimulant and biofertilizer for our local agriculture industries. And biofuel, for example, ethanol. But unfortunately, biofuel from microalgae, they are not being commercializing yet because it's very difficult to compete in terms of the cost with a normal oil and gas, price. Like for example, ethanol, if you want to compare with the gasoline price, especially in Malaysia, so it doesn't compete it because at the current stage, the production cost of ethanol from microalgae is around 20 to 25% higher than the normal fossil fuel that we have, right? So most of the company, they have yet to establish on microalgae for biofuel, but they have already established in terms of pilot testing, but they are not commercializing it yet, right? So bioethanol still at the pilot scale, not commercial. Okay, right. So let's look on the problem and challenges when you're dealing with the microalgae. When we look at the potentials products, when we look at the advantage of the microalgae, it's very, very, interesting. It's very promising. It's very, profitable in terms of the business market and whatnot. But when you start dealing with the microalgae, it comes with 1001 issues. It's not easy. On paper, it's very easy to grow it because, you have the methodologies to produce the microalgae, but in real applications, you cannot control. There is many issues like us, right? Your parents to grow you up, they are facing many challenges. There is some kids that's very easy to handle, but there is some kids are very difficult for them to handle because we are dealing with living things. We have the emotions, we have our own attitude, we have our own preference. So it's similar like microalgae because it's a living things. There are the days that they are happy growing. There are the days that they don't want to grow. There are the days that when they have a very hot or high temperature, they died. And then there are the days that when you have a very, when you receive a lot of raining throughout the day, they don't produce it in the maximum because the temperature reduce, right? So this is something that we have been facing in terms of the environmental conditions because we cannot control the environment unless you culturing it in the indoor environment. Then you can control it. But when you start bringing them to outdoor, so it will expose to many environmental conditions to produce them. So it become inconsistency to producing that microalgae. So the number one issues that I would like to highlight here is basically in terms of the contaminations, right? So if we look on this, oh, it doesn't work. Yeah, all right. So this image, it should have an image. Okay, that's all right. So contaminations, meaning that it comes from the zooplankton, it comes from the bacteria, it comes from the microalgae itself, it comes from the viruses. So where these contaminants coming from? It can come from the water that you use. For example, if you use the marine water, if you don't treat the marine water, then you will bring up all the bacteria and protozoa from that ecosystem into your microalgae environment. So because the feed or the nutrients that you supply to microalgae is the same nutrients that being consumed by the other bacteria populations. So it become a competition. And although you are culturing in one single species, but sometimes there is other species of microalgae present in that ecosystem, then it become a competition, right? So number one is the contamination. So it's very difficult for you to have zero contaminations, but you can put the strategies to minimize the contaminations when you culturing the microalgae. So how do we control it, or how do we minimizing it? We can use a chemical control, we can use a biological control, or physical control, or environmental control. Okay, so so it depends on your application, which one that you can apply. But from my point of view, based on my experience, I think the physical and chemical control is the best compared to the biological control and environmental control. Because environmental, of course, is very difficult for you to control in terms of the temperature, in terms of the light, in terms of the salinity and whatnot. But for the physical control, you can install the UV lights to kill all those pathogens before they come to the algae, or you can do sterilizations to kill all the microorganisms. Then you can get a very clean environments for the algae to grow. And then chemical controls, you can put the normally we put the chemical agents to kill this all the unwanted contaminants, right? So the number one issue is contamination. The second issue is in terms of consistency of the quality and productivity, because when you grow the microalgae, these are the parameters that you have to taking care of in terms of temperature, because some species, they cannot tolerate a high temperature. Some species cannot tolerate in a very low temperature. So you need to have the ideal temperature to grow the microalgae. So in terms of salinity, in terms of the pH, it cannot be too acidic, it cannot be too alkaline. It should be in a natural pH for them to grow. In terms of the CO2 concentrations, you cannot put a very high CO2 concentration because it will affect in terms of the pH later on, in terms of the lights and the mixing. So you cannot mix very fast because you will kill the cell. So you need to have a very sufficient mixing speed in order to make sure that they interact between the nutrients and the cell, right? So these are the things that you have to control. And when you're controlling it, it comes a cost, right? So if you don't control it, then it has an issue in terms of the consistency of the quality of the biomass, right? So the third issue is in terms of sustainability. How do you produce the microalgae in a very low cost, low energy, but you want high efficiency, right? Because if you're producing the microalgae in a high cost, then the microalgae powder that you want to sell to the market will become higher, then it will become another issues for the manufacturer to produce a product in a cheap cost. So this is some of the balance that people have been discussing and trying to resolve to produce a microalgae in a low cost, low energy, and high efficiency, right? So you can control it in terms of the microalgae production system, the selections of the photobioreactor, in terms of the nutrients that you use and whatnot. So there is many things that we can discuss. I think we can elaborate more when we have the another sessions later on. Okay. So this is the project. I would like to share the project that we secure for the past 5 years. We started the project in 2018 until 2023. We received a huge grant from Japan, which is, we call it as a Cosmos project, where we call it as a continuous operation system for microalgae productions for sustainable tropical aquaculture. So what we are doing in this project is actually we are utilizing the waste that coming from aquaculture pond, because in the shrimp, they are producing a lot of, we call it a sludge, right? But it's actually the sludge content a very high nutrients like NP, kan, ammonia and whatnot, that we can use as a food for culturing the microalgae. So the current applications in the aquaculture pond, they just discharge to the to the environments of the sludge, and then it will have the issue in terms of the environmental issues, pollutions, right? So what we do is basically we recycle this aquaculture waste, and then we produce carbon and nitrate from the waste. There is the aerobic fermentations, and then we use that to culture the microalgae, right? So from the microalgae, and then we turn into a feed or supplements for human. Then it become a circular economy concept where it creates a zero discharge and protecting the environments from pollution. So it's one of the examples of how you integrate the microalgae with a circular economy concept for this project. From the aquaculture waste, and we are turning into a very high valuables ingredients for the microalgae, and the microalgae turns into high value products from that, right? Okay. Right, so the fourth issue.
Prof. Razif,
Yes.
I'm sorry for the interruption because
Yeah.
we have a limited time and we
All
still
right,
have
sorry.
another question and answer session. I
Okay.
just want to kindly remind you, is it okay if we wrap up around 5 minutes or so?
Yes,
Is it
yes.
okay? Okay.
I already completed only 3 more slides.
Okay, okay. I'm sorry for the interruption.
All
Okay,
right,
you can
no
continue.
worries. Thanks for reminding. All right, because as a lecturer, we love to talk. Okay, sorry. Okay, the issue number 4 is the cost competitive. Like I said, how you make sure that you have a very low production system with less energy. Okay, so this is how the research on the microalgae has been changes from for the past 10 years. We are looking on which species that are very suitable for product development, and then we look at the engineering part in terms of designing the production system, and then now we're looking on the algae biorefinery. So how to make sure that the algae is producing in the sustainable way, and then how to make sure that the algae is producing in a very high productivity and low cost for different product formulations. Okay, so the remain challenge, reaching a world-scale productions and then achieve the economic viability within the products, and then of course achieve in terms of environmental sustainability. So the last questions that I would like to highlight is when people keep asking what is the best microalgae production system. The answer is we don't have a specific answer to it. It depends on what species that you are using, which area they are using, whether you have a very good sunlight, basically in the tropical climates, or whether you are in the 4 seasons countries. So it depends. It depends on variable input characteristics, depends on how much the carbon that you have, how much the nutrients and whatnot. And it depends on which product that you're looking at. Either it's a low value products, for example, fertilizer compare with the biofuel. So it depends, and you have to be ready to adjust in terms of the cost and energy to produce the product. So that basically it from today's sharing. So I would like to open if you have any questions about microalgae. I'm happy to resolve the issues that you have related to microalgae. So I pass back to Ms. Rizky for these sessions. Thank you.
Okay. Thank you so much, Prof. Razif, for such an insightful and eye-opening session. Yeah. So now, student, I think this is your moment. We have a few minutes for question. If you want to ask something was just spark for today's session or something you have been wondering about for a while, please do not hesitate because there's no wrong and truly no wrong and no good answer question in here. So I would like to call some name because I have several names that want to ask a question. The first one is Laila Witra. Laila Witra. Okay, can you stand up and come to the front of the class so we can see your face clearly? Okay, Laila Witra, is there any question that you want to ask for Prof. Razif?
No, before, thank you for the opportunity, Prof. Razif.
Can you come closer to the mic because we cannot hear your voice clearly? Okay.
Thank you for the opportunity, Prof. Razif, and thank you for your lecture today. It's give me a new insight, especially when you mentioned about the cultivate system of microalgae. So my question is, while listening to your explanation, I became curious about the open cultivation system. Since the system is more prone to contamination and evaporation, why is it still widely used instead of switching to a closed cultivation system? Also, how can contamination and evaporation using an open cultivation system be reduced so that production remains optimal? Can you get it, Prof?
All right. Thank you very much. Very, very good questions that you have been asking. All right. Like I mentioned earlier, that the limitations of the open pond system is prone to the contaminations, right? But still, people or the industry still adopt that open pond system. So in order for you to use the open pond system, number one is you have to select the species that are very robust, right? So the species itself, for example, chlorella, they are not prone to contamination. I mean, they're not easily to be contaminated by the other bacteria or pathogens because they have a strong, we call it as anti how can I say they shielded itself with a very strong cell wall. So when the pathogens coming in, so they are still growing without degrading their cells because this is how the characteristics of the chlorella. So in order for you to use the open pond, you have to select a suitable species to it, right? So if you look at the most of the people doing open pond, they are using two species only, which is Prolina and then Chlorella, because these species are very high tolerance in terms of the contaminations, right? Okay, so that's one. Your decision if you decided to use an open pond system. The second one, the open pond system has been used as a second step for mass cultivation, right? So the first step is basically they will culture it in the photobioreactor at the indoor. So they culture the microalgae to make sure that microalgae are very at the healthiest conditions, right? In the indoor, under the controlled environment. Then they will transfer from the closed system in the photobioreactor to the open pond system, so that when they are exposed to the open pond system, they are already at the healthiest stage. So they are very matured, right? Like you, when you during your kids, you still under your parents' guidance, right? So whenever that you want to go, your parents will follow because you are not really matured. You cannot make decisions. But at certain time, when you getting matured, then your parent will release you to go out. And whatever the conditions that you're facing outside, you can control yourself. So this is the same concept where the open pond system has been used as a second stage to produce the mass of the biomass. But you have to do the first step first, which is under the control, which is indoor. Right. So that basically my explanations on it.
Thank you, Prof. So not every species are suitable to use to cultivate by the cultivate system. So it depends from the species. Is it
Yes,
correct?
correct. Not only species, but it depends on your applications, right? Like, for example, if you want to produce a biofuel, you can go for open pond system because biofuels, whatever the algae that you have, you can extract the lipids. But if you want to go to the food applications or pharmaceutical applications, you need to control in terms of the toxicity of your microalgae. So you cannot culturing it at the outdoor in the open pond. You have to doing it in the control environment. So it depends on the species. It depends on your products that you want to produce.
That's very clear, Prof. Thank you for your answer.
Yeah, thank you very much for very brilliant questions.
Okay, thank you, Layla, for your question. And I have another name that will ask a question from Neni Rahayu. Neni Rahayu, are you there? Neni Rahayu. Okay, can you step forward so we can see your face and heard your voice clearly? Okay, Neni.
Terima kasih Bu. Sebelumnya saya minta maaf masih menggunakan bahasa Indonesia.
Tak apa. Bisa.
Terima kasih atas kesempatannya. Saya di sini izin bertanya, Prof, tentang pada proses produksi mikroalga kan terdapat pemanfaatan karbon dioksida, cahaya dan limbah nutrien itu sendiri untuk menghasilkan biomasa yang kemudian
laju sangatlah. Sabar. Laju sangat. Bertenang, ambil nafas. Okay.
Proses produksi mikroalga kan terdapat pemanfaatan karbon dioksida, cahaya, dan limbah nutrien itu sendiri untuk menghasilkan biomasa yang kemudian itu diolah menjadi biofuel. Nah, bagaimana proses tersebut itu dapat dikatakan lebih ramah lingkungan dibandingkan itu sumber energi lain, padahal produksi mikroalga tetap memerlukan energi seperti cahaya dan proses ekstraksi itu sendiri. Nah, selain itu, bagaimana sih keseimbangan peran mikroalga sebagai produsen primer di ekosistem perairan jika pemanfaatan biofuel ini terjadi secara besar-besaran? Apakah ada dampak lebih lanjutnya terhadap ekosistem? Dan jika ada dampaknya itu, bagaimana sih cara mengatasinya begitu? Terima kasih, Prof.
Prof. Razif, can you catch up the question or she needs to explain it again slower?
Yup.
Neni, boleh dijelaskan lebih pelan-pelan?
Let me try to analyze the question. Okay. Kalau saya tidak salah, kamu menanya microalgae memerlukan energy untuk produce the biomass, betul? Alright. Tapi at the same time, kita gunakan biomass to produce energy, biofuel. Alright. So, bagaimana? Adakah itu balance? Microalgae perlukan energy untuk produce biomass dan biomass itu tu. Sebenarnya, the photosynthesis proses terjadi secara naturally di microalgae. So, it's actually kita bukannya ada continuous producing energy. So, kita produce biomass dulu. So microalgae keep on producing the cell. So from 1 cell to 2 cells, 2 cells to 4 cells. So it keep producing the cell. So while they're producing the cells, kita akan stop the production and then ambil biomass tu and then keringkan dan guna biomass untuk producing biofuel. So it's a different step. So kita produce the biomass dulu, and then baru kita producing the energy. We are not doing at the same time. They are producing biomass, and then at the same time they're producing energy. No, it's not a continuous process to produce it. We have stage by stage. So kita biarkan dia produce banyak-banyak dulu, then kita stop productions, then ambil biomass tu and then producing the energy. So it's a two different process. It's not one step. Okay. Okay. Yang kedua tu kereta apinya laju betul. So saya tidak dapat tangkap. Apanya soalannya yang kedua?
Pertanyaan kedua, boleh diulangin lagi dengan lebih pelan-pelan?
Ya, baik Ibu. Nah, tadi kan pemanfaatan karbon dioksida mikroalga, produksi mikroalga itu kan terdapat pemanfaatan karbon dioksida, cahaya, dan limbah nutrien itu sendiri untuk menghasilkan biomasanya. Yang kemudian itu diolah lagi menjadi biofuel. Nah, bagaimana proses tersebut itu benar-benar dikatakan ramah lingkungan itu dibandingkan sumber energi lainnya?
Oh, okay. Alright. Sumber energi lainnya maksudnya contohnya apa? Solar ke apa?
Yeah, I think she asked about the dibandingkan dengan solar, gasoline,
okay.
ya.
Okay. Okay. Dia how can I describe this? Okay, compare dengan it depends on different applications. Macam microalgae untuk biofuel is actually they cater for fossil fuel base. Contohnya solar for electricity kan, tetapi microalgae ni digunakan bagi menggantikan diesel, bagi menggantikan gasoline, gas. Ia tidak menggantikan sumber elektrik seperti itu. So dia sebenarnya tak boleh dibandingkan. Dia sebenarnya complement. For example, solar for electricity, microalgae for transportation. For example, something like that. So they are complementing to make it one complete renewable energy in each country. So yeah, dia kalau kamu nak bandingkan fossil fuel versus microalgae fuel, then boleh. Tapi kalau nak bandingkan dengan energi lain, it's very difficult lah sebab it's different application.
Is it clear enough, Neni? Okay, sudah, Neni?
Okay. Terima kasih, Neni, for your very great questions.
Terima kasih.
Okay, thank you so much, Neni and Laila Witra. As we have a limited time, I'm afraid that we will need to wrap up our Q&A session in here. So if you have any further question, I think Prof. Razif will be happy to connect with you outside of this session, right, Prof. Razif?
All right.
Okay. So thank you once again, Prof. Razif, for your time, your expertise, and your passion for this field. It truly shows. Okay, our student, with this we have now reached the closing of the day session. But before I close this session, we have an exciting announcement to share with everyone, because on the 19th of June, Prof. Razif will be visiting Indonesia, and we are thrilled to have him join us for an on-site lecture in Jepara, in Teluk Awak, Jepara, that arranged by the SEMEPSA team together with Prof. Natra. So Prof. Razif not come alone in Indonesia. There will be Prof. Natra from University Putra Malaysia. And I think this will be a wonderful opportunity for you, all the students, to learn directly from two leading experts in their field. So at Marine Science Technopark Jepara. So I think it's truly a rare and valuable experience. So if you have an interest in marine science or microalgae or microalgae engineering, I think you would love to learn from their experts. So we strongly encourage you to join this session. And if you have if you need more information, you can feel free to reach out Kak Elang dan Kak Laili ada di sana gitu. And we will also be sharing the registration link through your respective coordinator. So please, you can join us. Okay. We hope to see many of you there. Okay. So I think that's enough from me. This marked the highlight of our program. So we hope that what has been shared from Prof. Razif today has sparked something to you, a new perspective or a research idea. So once again, please welcome big round applause for our wonderful speaker, Prof. Razif. Boleh tepuk tangan teman-teman?
Terima kasih. Ya.
Okay, so I will give it back to Prof. Sabta. Thank you so much, Prof. Razif. See you on June.
Thank you very much, Miss Rizky. Yep, see you.
Yeah. Oh, it's a very good presentation. Lots of the very informative, and then lots of the knowledge that the students need for that. Thank you very much for Razif for giving such a wonderful presentation for today, giving lecture. The students also very exciting. So now it's come to the end of this session. So I would like to express my gratitude, to you by giving a certificate, just symbolized the certificate. I will share to you the kind of the certificate here.
Thank you very much.
Yeah, this one is the certificate.
Oh, very
And
lovely. Can I take photo for a while?
yeah,
I just
let me check it again. Sorry. Hang on. I have another this one.
Oh, okay. Oh, you AI me.
Yeah, you see that?
Oh, very high tech, eh? Oh, yeah. Very glad to see.
Yeah, this look nice, right?
It's very nice. Yeah.
Yeah. So just symbolize that I give you appreciation by giving the certificate, and actually the real one will be given to you in the name when you come here.
Yeah. All right. Okay.
Yeah. Thank you very much.
Okay. Thank you
Well,
very much. Yeah, very,
yeah.
very excited to see the AI.
We all look younger, right, both?
Yes, of course.
Okay then. So, so close to the end. Oh ya, Bu Rizky sudah memberitahu tentang salah satu agenda yang sangat penting dan bagus untuk kalian ikuti ya. Tapi mohon maaf untuk partisipannya limited, sehingga nanti saya kasih linknya untuk di sana ada CV, your CV. Nah nanti based on your CV nanti saya akan pick lah yang mungkin sekitar 10 terbaik dari kalian ikut partisipasi di sini. Oke? Oke ya. Nanti submit ya. Nanti saya share lewat Putra. Mana Putra? Masih ada di sini Putra? Oke, saya share nanti Putra ya, G-form-nya untuk diisi dan kalian isi dengan CV kalian ya. Oke, so all expense will be covered ya oleh kami panitia ya, kami tim ya, tim Semepsa akan cover perjalanan kalian, makan dan semuanya, tidak termasuk jajan atau beli-beli kopi itu di luar itu ya. Kalau beli kopi mah biasanya saya nunggu di traktir Prof. Razif nanti di sana kan suka ada kopi juga. Zeus Coffee, very nice. Zeus Coffee, ya. Oke, kita close saja ya sekarang. Thank you once again ya, Prof. Razif for deliver very nice topic, very interesting. So see you for the next time in the next agenda. Thank you very much.
Right.
Saya tutup ya, Bu Rizky. Thank you
Thank you very
again
much,
untuk
Prof. Sabto, for having me in these sessions. I really appreciate, and thank you to the students. Bear with me during the sessions, and thank you for your participations. And of course, I look forward to meeting everyone next month in Undip, and hopefully we can discuss further if you have any interest on microalgae. Thank you. Terima kasih Pak Profesor Sabto and Bu Rizky.
You very welcome, Pak Razif. See you soon then, ya.
See you.
Yeah, we off now.
Alright.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Have a good day, everyone.
Thank you,
Yeah.
Prof.
Thank
Razif.
you.
Oh ya, don't forget to fill the form ya. Don't forget to fill the form ya. Untuk student ya. Jangan lupa ya. Itu Putra kasih tahu ya ke ini ya.